Hey guys, this is Mr. Anziano. I am going to record a quick video on 4.3 Notes Example 2. This one's kind of a doozy, so I may be pausing from time to time to kind of gather my thoughts. You are definitely going to want a calculator handy, so I'm going to have Desmos available. I suggest that you go ahead and do the same right now. Alright, so I've got my handy dandy calculator at the go. Why don't you guys do the same? And here we go. First of all, we need to look at what the question is asking us here, right? So for example 2, they're first stating that we are to graph the line defined by the equation 2x plus 3y equals -6. Okay, now I want to put that into slope-intercept form so I can graph that by hand with ease. So what I'm going to do is move the 2x over to the other side and then divide everything by 3. So let's see what happens here. That equation is going to turn into 3y equals -2x minus 6, right? Not quite in slope-intercept form yet, though. Divide everything by 3. And we get y equals -2/3 x minus 6 over 3 is just 2. All right, so now we're in slope-intercept form, and that looks like it should be pretty easy to graph. So I'm going to have my straight edge here. And let's see, we start at -2 because that's my y-intercept, and from there I'm going to go up 2 and left 3 to get that first point, down 2 and right 3, right? Rise over run is -2 over 3, so my next point is going to be down 2 and right 1, 2, 3, and there are 3 points that I can now connect to create my straight line. Okay. I'm going to make my line a little bit wide so we have some tolerance on our intersection points. Okay, now the first thing that I notice is that my intersection points between the line and the circle are not really at nice values. So what that means is that we're going to have to use a slightly different method to get the solutions here. Notice how the instructions don't say obtain the solutions graphically, right? It's simply asking us to algebraically find the points where the line intersects the circle. So let's see what happens here. We know that we can use substitution from our discussion earlier in class. We can plug this expression that we got right here for y back into wherever we see y in the other equation, right? So we're going to substitute -2/3 x minus 2, this guy right here. We're going to substitute that expression in for y in both the y squared and the 6y. So believe it or not, we're actually going to need most of this space, this entire zone here, so you might want to write a little bit cautiously, maybe small. Here we go. We are going to first start by writing x squared, right? X squared plus, instead of y squared, that's going to turn into -2/3 x minus 2 squared. Okay, so we have our x squared, we have our y squared, now we have 2x, so plus 2x, plus 6y is instead going to become 6 times that y right there, right? So plus 6 times -2/3 x minus 2, and then plus 1 right there is equal to 0. Okay, well, this is going to be a lot of combining like terms and figuring out what we're left with. So first thing I'd need to do here is expand -2/3 x minus 2 squared. So in my next line, I'm actually going to do just that. I'm going to write out -2/3 x minus 2. For me, it helps to just do it like this and kind of FOIL times -2/3 x minus 2, especially when the expression is a little bit unique, right? So now I notice that if I multiply my first terms, right, in FOIL, first, outer, inner, last, we have -2/3 x times -2/3 x gives me positive 4/9 x squared. And then my outer terms are going to be -2 times -2/3 x, right? And my inner term is going to be another -2 times -2/3 x. So those terms are going to be the same. And I know that -2/3 x times -2 is actually positive 4/3 x. So really what I have is two 4/3 x terms being added together. So that middle term is just going to be plus 8/3 x. Okay. And then we have -2 times -2 is plus 4. All right, so now that that's out of the way, I'm going to write my next line here. So when we bring it down, we have x squared plus 4/9 x squared. From that work that we just did in the previous line, we have 4/9 x squared plus 8/3 x plus 4 plus 2x. Now we have 6 times -2/3 x. Okay, now two ways to do this, right? We could do 6 times -2 all over 3. That's -12/3, which is 4. So that's going to be a -4x, right? Or we can just say, what is -2/3 of 6x? And still we get -4x as our next term. Okay, and then we have 6 times -2 is -12. And we can't forget this plus 1 at the end right here. Okay, so we've got plus 1 equals 0. All right. Now, I need to combine like terms. I have this x squared term right here, and I also have this 4/9 x squared term right there. Now, I know that x squared is the same as 9/9 x squared, right? That's just 9/9. If it's 1, we have 9/9 x squared. I'm going to turn that into a 9/9 x squared just so I can add it with 4/9 x squared. Then I also have, for my x terms, 8/3 x plus, we have, I'm just going to circle the x terms actually, so I can kind of keep track. So 8/3 x plus 2x is actually going to result in, again, I know that I can turn 2x into 6/3 x, and I know that I can turn -4x into -12/3 x. Now my constant terms are 4, -12, and 1. I lost my light, so I'm just going to turn the light on there. Okay, let's see. So if those are my constants, I know that I'm going to have 4 minus 12 is -8. -8 plus 1 is -7, so that's my constant. Now I'm going to add up all of my like terms. 9/4 x squared plus 4/9 x squared is going to be 13/9 x squared. And then we have plus 8/3 x plus 6/3 x minus 12/3 x is going to be 14/3 x minus 12/3 x. So really that's just going to be a plus 2/3 x. And then minus 7 is equal to 0. Now, in order to do anything with this, to see if it's factorable or to potentially have to maybe try something else, I first need to get that x squared to not have a fraction in front of it. So I'm going to multiply this entire equation by 9 to get rid of that denominator. Okay, so let's see what happens here. If I do that, I'm going to be left with 13x squared plus 2/3 of 9, right? Or 2/3 times 9 is just going to be 18/3x, which is really just 6x, right? Or 2/3 of 9, again, is 6, and so we have 6x. And then we have minus -7 times 9 is going to be -63. So, as of right now, we're thinking, oh gosh, does this look factorable? And I'm going to make it easy on you. It's actually not, so don't even try. We can kind of tell that this isn't factorable, so we know that we can at least try and use the quadratic formula. All right. Now I'm going to go ahead and use the quadratic formula and go through the process. It's good practice for us to just make sure that we're okay with numbers and that we're feeling confident with this quadratic situation. So first we need to write out the quadratic formula in case you forgot. So I'm going to write out the formula. It looks like x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you were singing the song that goes along with it. That's how I remember. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Well, we've got an A here, we've got a B there, and we've got a C there. So I have all of the pieces that I need. Now I just need to plug it all back in. So let's see what happens here. We have x equals -6 plus or minus the square root of 6 squared minus 4 times A is 13 and C is -63. All right, now this is where we're going to want to use our calculator. Okay, and I'm going to turn the brightness off for just a moment. That doesn't really help. Hang on, let's turn the light back on and turn the dimness down. All right, that's a little better. So what I'm going to do is I'm going to just add 6 squared and then, take 6 squared and subtract 4 times 13 times -63. So let's just see what that is. 6 squared minus 4 times 13 times -63 looks like 3,312. Okay, well, before I forget though, I need to put that all over to A, and A was 13. So that's going to be over 2 times 13. Okay, so now for my next line, that's where that 3312 number that we just got right here is going to come into play. So I have x equals -6 plus or minus square root of 3312, 3,312, all over 26. Okay, and again, calculator time. Let's see what happens. We know that we're going to get two solutions because we're taking -6 and both adding this amount and dividing by 26 and then subtracting that amount and dividing by 26. So that's the bell. I'm going to try and finish this up real quick here. What happens is the square root of 3312, first of all, is, square root of 3312 is 57.550. So really that's -6 plus or minus 57.550 all over 26. So my first solution is going to look like -6 plus 57.550. And we're going to take that thing, put it in parentheses, and divide by 26. Okay, so my first solution is going to be x equals positive 1.983 is what that looks like. And then if I take the converse of that, if I subtract 57.550 and divide by 26, I get -2.444. So what that's going to turn into is basically we have these two solutions for x. All right. Now all I need to do is get the y values that go with it, right? So I'm going to take my equation right up here, this y equation, okay, and I'm going to plug in both 1.983 and -2.444 and see what happens. So -2/3 of 1.983 minus 2 equals, let's see here, -2 divided by 3 times 1.983 equals -1.322, and then -2/3 times -2.444 minus 2 is going to equal, oops, I forgot to subtract 2. That should be -3.322. My apologies. -3.322 there. And then if I replace that 1.983 with -2.444, I get -0.370. All right, so those are my y values. So really my solutions in the very end are going to look like this. We have 1.983, comma, -3.322, and -2.444, comma, -0.370. Look back at the graph, make sure that those coordinates right there seem legit, that they might be where the circle intersects the line, and you should see that that looks okay. All right, have a great weekend, guys.